Thanks very much, folks. We're going to kick off this session with Kumar from Bing. He's a long-time engineer in Microsoft and now runs the production engineering team, and he's going to talk about my service runs at 99.99999%. All those tweets about outages are not real. So I'm very interested to hear this. Thanks, Kumar.
Yeah, thanks, man. Thanks for the intro. Yeah, so my title is quite long. So originally I thought I'll include the synopsis in the title itself when I was submitting the talk. And then I ran out of characters, so I had to separate out the title and the synopsis. So I actually haven't heard an excuse like this in my job, but I've heard various excuses whenever I talk to service engineers or teams, engineering teams, about how their service is doing. And when there's an issue, oftentimes it's because they have an actual issue, but their metrics don't reflect them. And sometimes they just aren't aware, or they're newer teams. So there's various reasons why I've seen cases where teams don't fully understand what their availability is. So yesterday, during the talk that Greg was having, the AV system had multiple problems, and I actually saw multiple people tweeting about it. So I thought it's actually timely to just include a couple of tweets about the uptime and the availability of the AV system. Since then, I haven't seen any outage, but I just felt like this fell into my lap where people are tweeting about availability of the projector system, which I thought was hilarious. To start with, given I'm talking to SREs from all over the industry, I'm pretty sure everybody is familiar with the metrics here, but I thought I'll just quickly go through. How many of you haven't seen a table like this which talks about availability and the downtime minutes and hours? Okay, some haven't, that's good. Services come in all shapes and sizes, right? So you have all the way up at the top, which is things that are running at 90% availability and all the way down to 9 nines. So at 1.9, you have approximately 36 days of downtime that you could have, and it would still be 90% available. 90% doesn't sound as bad, but if you say something like you're down for 35 days of a year, that sounds incredibly bad. So over the last few years, as I've been working on Bing, it's been very helpful to transition from purely talking about 2 nines, 3 nines, and 4 nines to talk about how much downtime minutes do we have. That's actually helped change the discussions I've had. It's a lot easier to talk to the product managers and others to tell, hey, your customers are not going to see your product for this many minutes per week and all that. And the other one is, especially for newer engineers, it's also been very helpful. In terms of services, you have services that are okay to run at 1.9. For example, there are services that power parking meters. Whenever your money that you put in the parking meter goes down, they actually ping the cops to come give you a ticket. I don't mind that running at 90%. In fact, it can even go lower. 0% availability, I'm okay with it. But all the way at the other end, if you're doing nuclear launches, or you're working in NASA and doing rocket launches, or even, I wear glasses at some point, I might go into a LASIK surgery, I would want that service to have a very high availability. Even 9 nines sounds scary to me, because what if I'm the one person who is going to get a bad surgery, right? So there are some services where the availability is extremely critical. For a service like Bing, somewhere in the middle, 3, 4 nines, that's, I would say, is an appropriate availability, mainly because we have taught people over the years that in the browser you can hit refresh and things most likely work. So that's been the trend. I have this super simple formula that I use for the rest of the talk when I talk about availability and how we measure. Really goes with, you have a service which has a whole bunch of requests that are coming in, and you take the total, subtract the failures, and divide by the total, and that's your availability. There's a lot more variations and more complex formulas on how you measure and quantify each one of these. While the formula sounds very simple, there's a ton of things that can go wrong with a really simple formula like that. So what I'm going to talk next is a series of things that actually went wrong that I've seen in teams that I work with, where a simple formula like this actually went wrong. Since I work on Bing, a lot of examples I'll use are from my job that I did there, and I'll go through some examples. Before I start, how many folks are here from Ireland? Actually, haven't met a lot of people locally. Okay, that's a good set of numbers. That's awesome. So incidentally, the head or the chief of Bing is Irish. He grew up in Dublin, Derek Connell. So that's a plug for Bing, I think. So I said I'll talk about Bing. Before I go to Bing, I'll talk about pizza first because I think it's very close to our heart as we work on our deliverables on a daily basis. Imagine you have a pizza company or a delivery service, and you have a metric which talks about how often you deliver pizza on time to your customers. So imagine the person gets the call, has the address, has the order. Instead of picking up from the pile of pizza that's full and fresh and hot, if he picks up from the ones that are empty boxes and takes it to everybody's houses and delivers that, the metric will still say it's 100% on-time delivery. The pizza box will look like this. There's some crumbs right at the bottom. Nobody would want this, right? This is an example of you're meeting your metric, which is your 100% on-time delivery, but you're not really delivering anything that's useful. We had an incident very similar to this. The empty pizza issue is what I would call. So the chart at the bottom that I have, it has a whole bunch of lines. I'll quickly explain what they are. So the top line, this squiggly line you see, is the overall availability of the service that had a problem. At the bottom, there are two axes as well. The one that's higher is the traffic that we were getting that day. So you can see the weekend versus weekday, there's traffic variation. And the red is the errors. Obviously, they're on different scales. Otherwise, they would fire me if we have that many errors. But the issue that we had, so this was, if you're used Windows 10, you have Cortana, that's right, the search box that's available on Windows when you're using it. When you first launched, there was a set of users, so it was not a global outage. For a set of users, when you go to Cortana, you're supposed to see all the interests that you have. Hey, what's the weather? Or if you like movies, you will have something about movies, or whatever people's interests are, don't know, sports and other things. Instead of showing those interests for the user, we were showing an empty or a blank canvas. So the issue was that it was a config error, which seems to be the trend for almost every incident I talk about. So the config update led a number of services to not return the proper results. So the UX service that was handling all this and doing the deserialization had an error, because of which the canvas was showing empty results. The way it works is you have the UX layer, which gets the results from various services. It packages them together and shows on the canvas. It turns out the UX layer did not consider it as an error because all the various components you have are optional, they're not required. So in this case, it turned out every one of the components decided they can be optional and didn't return any results. So it was a completely empty canvas, and the UX didn't track it as an error. So the graph here, the availability shows amazing availability. It didn't have any drop, but if you really look at what happened, you would have seen a big drop there. So that was one example where we realized well, the formula is simple. On the right hand, I marked the F as in red. The failures were the issue here. The formula is simple, but we didn't categorize the failure correctly, and that's what went wrong here. For this, it was actually pretty straightforward. We just had to go through, really understand the feature and understand the failure cases that we would have, and we had to go update the metric. And really, we had to understand and go through. There are explicit errors that we understand, but there are assumptions you make in the system, especially in a complex system like this, where you may think that things are running well, but not really. So the next chart I have is a similar graph design. Does anybody see any problem with this graph, an outage or a problem here? Any big drops or not? Yeah. So right towards the end, we see a small drop. You will also see that the volume has dropped during the day as it picks up to be night. There's lower volume. It turns out, this was at least the graph showed something. The real chart looked like this. So the downtime was significantly larger. The axis is so large that we go down to 30% or so. So this was for a region, for a particular experience, so not global. But the issue was that the availability was being measured at our application layer, and the application layer was logging every request that was coming in. It was comprehensive, and that was the total. And it looked at the failures that happened at that layer and determining this as what the availability numbers were. It turns out there was a layer above that, which is our edge network or the CDN, that was black holing some traffic. So the traffic wasn't even reaching the application layer. And whatever traffic was reaching, there was some portion of it was reaching, it looked at it and said, okay, of all the requests I get, which is significantly smaller, things look fine. My availability is great. So if you just go off of the metric that's there on top, plus we have fork traffic, test traffic, and all kinds of traffic that are hitting always, it's very rarely that we would see a zero traffic for any location or a service. So given that, in this particular example, the total was completely wrong. But the availability looked fine because it didn't handle that there was a big traffic. So this was not a mature service we had, so there's a whole bunch of things we had to do. One was we had to add some additional checks to see how do you track the traffic. It's not enough to just have the availability calculation. You need to know, did you have a big shift in volume? Did you have a big increase or a decrease? So those things definitely change the availability metric and how you look at the overall formula. So that's one thing that came in there. The other thing to look at is also sample sizes can affect your metric. In our case, we try to do the entire comprehensive logs that come in to calculate our metrics. But if you're looking at a smaller sample, that could actually show you much better or much worse availability than what you really have. So the other one is not as much availability. I didn't have a good screenshot, so last night I just put in a couple of screens that showed. The top one shows things were mostly nice and green. The bottom one shows that we have a problem in certain regions that we have. In this particular case, a class of problem that I've seen in the past is that you have there's a service that's running. There's dashboards, availability, and monitoring builds on top of that. The infrastructure-wise, behind the scenes, the service got upgraded to a newer version. The logging has changed. It's been logged to a different location, different position. The monitoring system wasn't aware of what was going on there, right? So because they were not connected together, they were disjoint. So one thing that we did with this is really now as a practice, pretty much with every service change, all the monitoring and the dashboards and anything else that come along with it are tied together, so there is this decoupling that can happen that can really show a problem that we would have. So I think I have two more examples. So like the original line or the title I had was every outage is a gift, but then I felt like, that's too intense, maybe it's not. And then I changed it to it's like a birthday gift, mainly because a lot of times it's a surprise. You don't know what gift you're going to get. Sometimes you like them, sometimes you don't like them. And then I don't like generalizations most of the times, so I changed it to almost. So the idea is that outages are really painful, right? So on the top left, the chart I have, or the image I have, is the panda being sad. So that's our designers trying to make our error pages look cooler and better. So originally we had this geeky error page on Bing, so they made it better. It's still bad because the user sees something that's broken. So this particular issue was an example where, in Bing, like most online services, we do tons, like thousands of A/B experiments. One of the experiments that we were doing had a config issue again, and that caused users that were on that particular experiment get errors, and they saw an error experience. So one thing that actually was a really good output that happened as a result of this outage was that our entire flighting or the experimentation system got a huge upgrade. We were trying to make that service or the entire platform hardened in the past, but it's actually not easy to get the funding and the right level of urgency. But this incident was, again, like a gift that I really appreciated, because users saw this error, so it was actually a lot easier. Now we improve the pre-production pipeline, and as like for A/B experiments, when a program manager or a product manager decides what kind of experiments he or she wants to do, they typically allocate what percentage of traffic do I want to allocate to this experiment, so they can look at it. It could be anywhere from 2 to 10 or 20% of traffic. After this outage, there's a whole bunch of work that was done to harden it. One, there's no experiment that starts up big. We have this concept called auto ramp. We start at 0.1% of traffic and then look at how the experiment results look like, look at the scorecard, automated, and then it has this feature called auto ramp. So automatically it ramps up the traffic in stages instead of getting it to a high percentage. The emergency shutdown feature. So the idea is that you have all these experiments running in production. Based on scorecards, you can tell which experiments are working well, which aren't working well. And we have this process which automatically looks for bad experiments and shuts them down so that we maintain a good user experience. So that emergency shutdown used to take anywhere around 7 or 8 minutes at the 95th percentile. As a result of this incident, the 95th percentile shutdown process is about 2 minutes, which is again, you can think of 8 minutes to 2 minutes doesn't seem a lot, but when you're talking about a user getting an error, that actually reduces significantly. Even though 95th is 2, or 75th is where we typically measure a lot of these metrics, they're significantly under a minute. So that was another thing that happened as part of this. The things that really came out, it's not just this incident in general. Things will go wrong. Every time it happens, it's really an awesome thing because we can go back to engineering teams. It's a lot easier to get funding for an area or work on improvements. You can show when things go wrong, and that's a lot easier. Talking about postmortems, I don't know if you missed Joy's talk this morning. She did a talk on postmortems and how to do that, or retrospectives, as she called them. Once the video is up, I highly recommend watching it. It was actually had a lot of good tips on that. And sorry. Thank you. And these things can really drive change. One thing one of our EVPs used to say is the thing that goes right at the bottom. Maybe I can say this in SREcon. So shit happens. But the key thing is that the same shit cannot happen twice. So that's the thing that we look at. Learn from it, make sure it doesn't happen again. That's the philosophy we really follow. Before I go to so there's a chart here that's actually not related to the incident. So when it comes to search engines, it's actually easy. Depending on the market, there are not so many players. In the US, you have Google, Bing, and Yahoo. That's like 1, 2, 3 in terms of the market share. So when we have an outage, clearly people go to Google or Yahoo. So that's one thing we try to avoid a lot because we don't want to have outages. So the chart that I have here so to give you a hint, I didn't follow the y-axis, zero fundamentalism, so it's actually not up to scale. You can see a big increase in the traffic for Bing. Any guesses on what happened there? Yeah. So it turns out one of our competitors had an outage during that time, so we got a bump in traffic. So the same thing happens when we have an outage, obviously, they get the traffic back. So I was joking to my friend saying that I could actually build a monitoring for them. They could ping me whenever they had an outage. I could send a signal saying, hey, we see an increase in traffic. Did you have a problem? Could be a side business I could do. There's a lot of business that we could do. The other thing, when you talk about failures, incidents, outages are a lot easier to handle. It's easy to explain to people, oh, things went down, we need to take an action. But steady state errors are a lot harder to explain to people. I mean, it's easier for SRE and it's easier for engineers to explain. In this particular case, like I have a service which is reasonably mature. I took a 1 month set of errors and looked at how much of the errors were from steady state versus incidents. They've gotten much better at getting rid of incidents, so their steady state is creeping up now. Imagine if you go to an exec or even like a program manager, if you say, your users, 10 million users in this 20 minutes saw an error, that's a lot easier to say versus 1 in 20,000 users in an hour might see an error. That's a lot harder to explain. So one thing we've tried to do a lot is doing the SLA-based ones and having the error budgets. We also use the budget of minutes, the one I talked about, and showing the overall impact really helps because that way you can say the steady state error can really creep up and make you miss your targets that you have for the year. The summary is really for me to see if I missed anything else that I talked about. One thing I didn't talk a lot about was debugging and diagnostics. A lot of these metrics are easy to build. One thing that I always find it hard for newer metrics again is once you get a number of 90.99, how do you get down to what was the actual error? Get the trace ID that tracked through the entire system, get the logs, looking at that. So that's an area that we've invested a lot in. Any questions? I think you have 2 minutes or 1.5. Okay, go ahead.
On your first example where you had the UX error,
yeah.
so that was not found by, I'm sorry, I'm not.
No, it's okay. You raised your hand for.
Go ahead. First example, UX.
Yeah, so that wasn't found by your automation. How did you actually find it?
Oh, so this was actually found by automation. So all the examples I showed were not showing monitoring gaps, but these are our official SLA metrics that we build and how they show the gaps.
Okay.
So we saw an error.
So you actually did get the
We did get the every one of these things we found through automation, but these are actual the availability metrics, SLA metrics that show gaps. Thank you. Greg?
Yeah, Kumar, I was wondering if you could talk a little bit about the data hygiene and how you triangulate to make sure that the data exists and it's all there,
Yeah.
coming from different
Yeah.
angles, so you don't have the same bug and then
Yeah.
the problem of no data.
Yeah, absolutely. Thanks, Greg. So Greg is talking about data. One thing when we talk about a lot of these metrics is it's easy to just go look at a stream of data and then go build metrics on top of it. One thing we try to do and work really hard is ensuring that the data that we have that is producing all these metrics is extremely accurate, and there is only one source of truth, there is nothing else. The way we do this is, one, we actually have multiple streams of data that we actually correlate between them. One is the real-time things that come in, right? Things that you can measure within seconds. The logs that are counters that are coming as part of the application. The second one is the real-time streaming, things like Storm and other systems that give you data in near real time. The third one is exhaustive logs that are actually based on service logs. We look at each one of them and do the join between each one of those things and look at, are there cases where there is some data fidelity issues and the other one we run into a lot is the bot traffic and other things, right? Especially for an online service. For us, more than half our traffic is bot. There's even after, that is after we classify them, right? And that's a known bot. So for us to and these bots can significantly alter your metrics because the traffic or the usage patterns these bots have versus real users have is significantly different. So we spend a lot of time on making sure that the data that we have, the quality improves. So every error and all those things, we take samples, we do exhaustive checks to verify these things. Thanks, Greg. Any last question?
Time for one very quick question.
One question? Okay, thanks everyone.